Today we're going to make this lovely and fully functional clock. It's intentionally spread out with the seconds, minutes, and hours hands on separate dials so that you can see the whole gear chain all spread out and not stacked up on itself like in a normal clock. And it has a battery-powered quartz sweep second-hand movement in the back, which means it actually works and will tell fairly accurate time. See the second hand moving. So let's get started building this. Now the first thing you'll notice is that in your kit, all the plastic parts come with a protective film on them, either a blue plastic film or a paper film. The first thing to do is peel off all the plastic from all the parts. We have a special video on how to peel film with minimal frustration. Good idea to watch it. And obviously I've pre-peeled everything. The first stage of construction is going to be to put together the individual gear shafts, one after the other with the proper gears on them. You'll see these little shafts here. They're like very small machine screws, number 2 machine screws, but with no heads. And there's 4 short ones, 2 medium, 1 long. We want the very longest one. Take that, and then we have 2 sides of nuts, the bigger ones and the very small ones. You want the very small number 2 nut. Pick one up and thread it on the end of this rod. And spin it down a little bit. Now, to measure the correct distance to spin it down, we're going to use these washers here. They're clear, they're about 1/8 of an inch or 3 millimeters thick, and we'll stack up 5 of these washers. If they still have the little cores in there, that's okay, just pull and it'll pop out. So 3, 4, 5 of those, and then adjust it so this is flat here, or like roughly flush here. The measurement is not critical, but roughly 5 thicknesses deep. And take those back off. That was just for measuring. And now flip it around and hold it so you're holding both the nut and the screw so it doesn't spin out of place. Now to find the right gear. So you see there's green gears and these amber orange gears. We want the very smallest orange gear. It has 7 teeth, not the one with 8, but the one with 7. Put that on, and then we want the tiny little green washer. It's much smaller than these, and it's green. That one goes on next. And then one of these 3 millimeter 1/8 inch washers, clear, goes on next. And now another tiny nut. Put that on, spin it on the end here. Sometimes they're a little finicky getting started, but that's okay. There we go. Alright, so spin it down, finger tight, and then there's 2 wrenches that it comes with, and put one on here and one on this nut, and after it's finger tight, something like 1/4 of a turn. It's about the right amount. It wants to be tight, but not too tight. If you make it too tight, it'll crack the acrylic. So firm, but not excessively tight. Okay, so that's the first shaft. We'll set that aside. For the second shaft, we use one of the shortest pieces and another tiny little nut. Get the nut started. Especially for these short ones. So there we go. Okay, so spin it on. In this case, we want 2 washers worth of space. So stick the 2 on, get it about right. And again, this measurement is not crucial at all. Flip it over to the short side, and now we want the 21 tooth orange gear. And you'll see it says 21 on it. It's the one that there's 2 of. And we want to put it on with the 21 facing forwards towards the nut that's already there. And then 2 of these small washers and another nut. And you should end up with about the same length of shaft on both sides. If not, you can adjust it a little bit, or just leave it because it really doesn't matter. Anywhere even close to the metal is fine. And again, use the 2 wrenches to tighten these down until it feels like it's right. I don't know. Okay, that's the second shaft. Now the third shaft, we again use a shortest one and a nut. Spins on, and again about 2 thicknesses. I'm just going to do it by eye this time. And then another one of the 21 tooth orange gears, again with the number engraving facing the nut that's already there. And then a small washer. And now we want the very smallest green gear. It also has 7 teeth. And put that on, and then another nut on the other side. Spin that on again, check for it being roughly symmetrical. Close enough. And tighten it down. Like that. There's the third shaft. Okay, now the fourth one, let's see, that's 1, 2, 3. The fourth one, again, is a shortest shaft. And a nut. Trust me, this will all make sense in the end when we put these together. So again, about 2 thicknesses in. And now we want the 8 tooth. It's the second smallest orange gear. Goes on first. And then another one of the, actually no, this guy, the regular clear washer goes on. And then the 28 tooth green gear goes here. And in this, you want the engraving facing towards the nut that's already there. And another nut. Spin that on. Again, check for symmetry. About the same length on each side. By the way, these wrenches here, they sort of have a sharp side and a smooth side, especially with the bigger gears. I like to put the smooth, the rounded edge towards the plastic just because I feel like it's a bit less likely to scratch. And tighten that. So there's the fourth shaft. Now for the fifth shaft, we're going to use one of the 2 medium length rods, now the longest ones that are left. That and slide on, also about 2 deep. And now we want the 15 tooth green gear. In this case, we do this the other way. So the engraving will face away from the nut that's already there. This one's going to go that way in the clock. And then one of the small clear ones goes on there. And then the second largest of the orange gears, 40 teeth, again with the engraving facing away from the nut that's already there. That goes on. And then another nut. Okay, and now you'll see this is not at all symmetrical. It's much longer on one side. If you want to double check that this is approximately 2 deep, you can do that, but it's really not crucial that it be exactly right. That was a little bit too long, so I'll back this up a bit. And then rounded side down to the gear. And tighten that. Okay, this is the minutes hand shaft. There. Okay, now another, the very shortest. Put that on, the normal 2 distance. And now the remaining small orange gear. Doesn't have engraving, so it doesn't matter. Small washer. And the remaining large gear. And this one you want to put it with the engraving facing the nut and the gear that's already there, like that. Put this nut on. Ah, we lost a nut. Well, fortunately, we give you an extra nut for exactly that reason. Okay, check for about the same length on both sides. Close enough. And tighten it. Okay, now the last one is again what was the medium length. Get screw or nut, again about 2 thicknesses in, like that. And now we put 2 washers on to start with, and then the remaining 48 tooth gear, orange, it goes with the engraving side away from the nut that's already there. So engraving visible this way, and then the nut. Check that still looks right. Okay, we're finished with gear shafts, finally. Now we can start preparing the frame. So there's 2 parts to the frame. This is the front side, this is the back side. We'll actually do a little bit of preparation of the back side first. So you'll see that there's this irregular spacing of holes, and on one side there's 4 extra holes here. With that on the left, like this, we want to take these 4 small screws. There's 2 sets of screws about the same length, but one is much smaller than the other. Those 4, and one by one we'll stick them in here, flip it over, and put a nut on. And spin this all the way down. And then you can tighten it using pretty much either the screwdriver or the wrench, either way. Okay, that's one. This is going to hold the motor mount on the back, and we won't actually do that until the very end, but we put the screws in now because after the rest of the clock is assembled we can't get to these holes anymore. So at first I did it with a screwdriver, now I can do, in either case you don't really need both because the plastic has enough friction that it tends to sort of hold in place. That's ready. Now we can start actually putting everything together. To do that, we're going to need 2 little supports. You could use 2 books. I would recommend 2 copies of my book, The Elements. It's good. But for now, we're going to use these 2 little plastic boxes. We just need something to raise it up a little bit. Spaced far enough apart so that the 2 ends are supported, but the 2 outermost holes here are not above the support. So, now holding this thing the correct way, so these words are reading properly, seconds, minutes, hours, take this and take the 4 larger screws and put all 4 of them through here. And then holding it this way, flip it over and set it down without the screws falling out. And leave it there. Now we need to distinguish several different types of longer washers. So you'll see there's a group of 8 that are 3/8 of an inch long, 9 millimeters deep. There's another group of 4 which are also the same length but have smaller holes. And then there's these 4 longer ones. We want the 8 that have larger holes. And those go on next. So check that they don't have their cores and feed 2 of them onto each screw. If you have a sturdier base, you can just sort of force them down. If you find one that does have its core in it, you can use a little screwdriver to pop it out, or just push it down onto the screw and that will pop it out. So 2 on each screw. Here I'm going to pop the core out using the screw, and it just pops out. Having a sturdier base to push down on is probably a good idea. I'll use the screwdriver because it's a very flimsy base. Push out the core. Those cores occur just because the laser cutter sometimes doesn't cut entirely all the way through. And this one is also giving a little bit of resistance, but it will always go through. Sometimes tighter than others. Okay, and all right, we've got all 8 of these washers on. Now we're going to start putting the gears in place. And it's most convenient to do that with the green shafts first, basically because the green gears, with the orange ones first, because the orange ones are ones that will be on the front. So let's start from the second hand side, which because we flipped it this way, the seconds will be over on this side. So these are in order, but flipped. So we start from this end. The orange gears always go towards the front, which is down. So we want to take one of these small washers, stick it in the end of the shaft on the side that has the orange gear, and that goes through the first hole, the rightmost hole, which is underneath where it says seconds. And then we'd actually do this one next. So that is this shaft, and put the washer on there, hold it with your finger, drop it in, and you see these are now connected. Then the next one, this is the one with an orange gear and a very small green gear. The very small green gear that we built wrong. So to illustrate what happens if you do it wrong, you take it back apart again. And what we did wrong in this case was the 7-tooth gears are so small that these clear washers are too big and they'll interfere with the teeth. So that's what the tiny green washers are for. Tiny green washer with the 7-tooth green gear. And put this back together again. And we won't edit that out because it's good to know that hope is not lost if you make a mistake, even in the official instructions video. So, tighten this back up again. There. Okay, now we again take one of these washers, goes on here, and holding it in place, stick it through that hole. Now we have 3 gears all together. Now we're not going to do the next one because if we did, it would then be hard to get the following one in. So we go to the next orange gear, skipping the green one there. And this one, so at some point these gears get to be so big that it's hard to hold the washer on. And at that point it becomes easier to drop the washer on there, and then again with the orange gear down, put it first through the washer, and because you can see through the gears, it's actually not that hard to find the hole. That goes on there. And then the next orange one, again, make sure the washer has its hole popped out. Put the washer, and then again skipping that hole, we skipped the hole there. Put this orange gear down through the washer and through the hole in the frame. And now it's time for the green one, so we'll take the leftmost green one and take the washer, make sure its core is popped out. It wasn't, so that's good, I popped it out. Oops. Set the washer there on top of the hole, approximately. And then orange gear down, so through the washer and through the hole in the frame, which is slightly harder to find this time. Okay. Now you may have to rotate the gears a little bit to get, because it has to mesh now with those, both the sides there. Okay, now the last gear. So again, put the washer down, orange gear down, and it goes through the hole, and wiggle it until it's there. So this is now all there, but it's not going to work very well because the shafts are held only on one side. But if it doesn't do this, if it doesn't actually turn all the way to the other side, something is wrong in the order, and you'll need to go back and watch the video again. Okay, so now we need to take the little washers here and put one on the end of each shaft. And if you're paying attention, you may wonder, why can I put a large size washer next to the 7-tooth gear? And that's because the nut, it provides enough space. It's not a problem. So every shaft, this shaft is longer, you'll notice, there's a reason for that, but it gets a washer also. So now we have a washer on every shaft. And now the exciting part, this also needs to turn around, and we have to put this onto all shafts simultaneously, which of course doesn't work. So we put it on one side first, and I find it's actually useful to kind of holding this at an angle, take these two nuts and just very loosely spin them on. Don't even get down to where the plastic is. That's just so it doesn't fall off on this end while we are trying to get it down through all the holes. Okay, so now we sort of lever it down, and it will touch, the first thing it touches is over here, and then maybe these two screws are next. And you just sort of have to figure out where is it binding as we're going along, and successively wiggle them into place. And each time one wiggles into place, it's kind of like picking a lock. Each time it goes a little bit farther down once you figure out which one is the holdup. Okay, I think this is now, yep, I think we're good. Now we can put these two nuts on. Spin those and then tighten these so they're snug. And now, be a little bit careful so the whole thing doesn't fall apart in case it's not actually together, but I think it's good. All the shafts are through, and it should now spin. So you should be able to spin it fairly easily like this. So at this point we can take the screwdriver and tighten these 4 screws. Get them basically as tight as you can using the tiny screwdriver. If you use a bigger screwdriver, you might have to moderate a little bit and not use too much torque. But with a little screwdriver, it'd be pretty much impossible to over-tighten it. Okay, so now we have the whole gear chain. You can even turn the hours and everything will go with it. And we can get rid of these supports. Now it's time for the 3 watch hands. So set this thing here and take one of the tiny nuts. Goes on the end of this shaft. And you can actually kind of, if you figure out which direction, you can actually use the gear chain to spin the shaft to get it to come on. Okay, there we go. Now we want to spin these down so that they're not quite touching the plastic. Good, millimeter or so, 1/16 of an inch maybe, off from the plastic. And then put one of the watch hands on. They're all the same because the dials are all the same. And then get another nut on. Spin that nut on. And now we want to tighten these, but we don't want to tighten them excessively because you actually want to leave them loose enough that you can turn them slightly without turning the gears, because that's how you can change the time, especially for the minute and hour hands. That's how you basically set the correct time when you first set up the clock. Okay, so spin that on most of the way. Watch hand. Nuts are difficult sometimes. Okay, there's that nut. And tighten it. Okay, just enough so that you can still move it without turning the gear. And finally, the last one. Just barely tight. Okay, so now's your last chance to play with it before we attach the motor. It will still spin nicely. Got that right. Okay, so once you're done playing with just spinning the gears for no reason, we can attach the clock movement that will make this into an actual usable clock. This is a battery-powered sweep second-hand movement, the kind that's nice and smooth, doesn't tick, no sound. And here are the various parts for mounting it. So start with this rubber washer. It has a sort of a depression, a ring inside here. Looks like a washer would go in there. That actually is for a raised piece of plastic here, so that goes down on the movement like that. And then this is the sort of mount. It goes on here. It actually makes no difference how you orient this. You can put the battery wherever you want. I'll put the battery, say, on the bottom. Doesn't really matter. So put that on. Then there's this flat metal washer. Goes on next. And then this large nut. And you screw that nut on. And it's not at all critical that this be tight. I think in the final kits we're actually going to include a laser cut acrylic wrench just for tightening this nut, but haven't made that yet, so and it's hardly even necessary because it's actually possible to get it nice and tight. Okay, so we got that mounted. Then these two little pieces, which hopefully you didn't throw away, this little metal brass piece has been sort of ground down. That goes on to the tiny shaft inside the larger shaft, and it just pushes on by friction. You want to push it on until it's firmly placed, but not, don't push too hard or you'll break it. And if you want to put the battery in at this point, we do give you a battery. It goes in positive side away from the spring. Get that battery in. If you look closely, you'll see this is actually turning now very slowly. It's the second hand turning mechanism, and we'll just leave it running. It's going to run for something like a year anyway on that battery. So now we need to mount it. Take this, put it face down, and we have 8 washers remaining, 2 long and 2 slightly shorter. Each screw gets 1 of each, so and these are a little tough to get on. So there's one long one, and if there's cores left in there, poke myself, use the screwdriver to poke the cores out. So that was one long one and one short one, and then another long one and another short one. Long, long, short. Core popped out. Short. Okay. And now we need to put this thing on that shaft. So this is actually a little bit finicky. So we want to take one of these tiny nuts. Oops. Tiny nut goes on here, and we want to spin it down about 3 millimeters, so roughly the thickness of one of these washers, down on the shaft. And then we want to take another nut, and this is the tricky part. So this is going to go on there with a nut inside that holds it in place. And the way to do that is to set the nut in there and then hold it like this so it can't get out. And I'll actually hold it like this so it can't get out and you can get this down. And then turning this shaft, it will hopefully catch the nut. And look at that, it worked. So it'll probably take you longer than that. I've done this a few times, but eventually you'll get that nut on. And then take something like a screwdriver and spin this nut. So you want to have the end of the shaft flush with the top of the nut, so there's sort of maximum clearance. And then spin this nut up tight. And then take the wrench and just holding that nut with your finger, tighten this a little bit. You won't be able to get it very tight, but that's fine because the torque on the second hand is extremely small. Yeah, that's, I mean, if you can turn it like this, you'll see there's virtually no resistance, and there can't be because the torque of the machine is, of the mechanism is also very small. And now you're going to take this and put it on here. I guess we'll put it on the screws, and then just sort of turning the second hand to get the C of that coupler to go on either side of the T-shaped drive pin there. When it's on all four, we're now slowly starting to realize that we only have 2 nuts and 4 screws. So hopefully 2 more nuts will magically appear. Must have dropped some somewhere along the way. This is sort of also a slightly irritating process of trying to get that nut on. So I guess I'll put one on diagonal sides until the 2 additional nuts magically appear in my hand. Look at that, isn't that amazing? So here's 2 more nuts. We actually ship these with at least 1, usually 2 extra nuts. So this should not be a problem for you. And get this last one on. The reason this part is irritating is because it's very close to the clock case. Oops. So it's sort of, where did that go? Well, it's just, oh, there it is. It's stuck on the side here. Okay, get this one on. Here's a little trick that I've used, is use the screwdriver to hold the end of the nut. Another trick is just to declare that we need to get the video over with and you'll get that nut on. So tighten these with the wrench. And pretend like I wasn't fumbling too long with that 4th nut. And then set it like this, it sits down. Now there's a fair amount of play here. That's intentional, so because the laser cut acrylic is not perfect enough to have a very tight fit there. But eventually, after a few seconds, the mechanism will pick up the slack and it will start turning. And there it is, a working clock. Since you left these slightly loose, you can set the correct time by moving these hands. And it should continue, you know, these things should be accurate to within a few minutes per year, roughly speaking. The accuracy is determined entirely by the accuracy of the quartz crystal in the movement in the back. The precision of these gears is irrelevant as long as they have the right number of teeth. So there you go, a working visible clock.